for this graph is all the possible x negative values and all the possible x and positive values. The reason is you can put in any input, so you can put in any number and you will get a result. You can also write this as x is the set of all real numbers. Okay, so all that just means is that x is the set of all x values in every real number, right? All the sets of real numbers. Just a fancy way of saying any real number works. For range here, we're introduced to this idea of asymptotes. Asymptotes is just this idea that there is an imaginary line that this graph will approach but never really touch. So the default for that line is y equals 0. The default for that line is y equals 0. However, when we move our graph up or down, then that asymptote moves. So as an example, this graph moves 2 spaces up, right? If we look at the transformations, they're adding a number 2 to the outside of our equation, so our graph is going to move 2 up. At the same time, we're going to have an asymptote here that's going to move, and it's going to be y is equal to 2. So that is really important to us because that means the range is going to, and you can see that this graph approaches y equals 2 on the downward trend. So the smallest value for this graph would be 2. It never touches it, so that's why we use a parentheses instead of a bracket, and it could reach infinity. So this graph keeps continuing on. It can keep growing, so the y values can keep growing. However, it never reaches below y equals 2. So 2 comma infinity is how we represent the range. Okay, so the second thing is end behaviors. Actually, intercepts is the second thing, but we'll talk about that in a moment. So the second thing is end behavior, and it's just that when the graph, so what is happening to the graph as it gets towards the end of our drawing here? What happens when the graph gets towards the end of our drawing here? Again, you can see that as x approaches negative infinity as it goes, as we put greater and greater negative numbers, what happens to our y value? Well, if you remember here, as we're getting lower and lower, going farther and farther left, our graph approaches y equals 2. However, it never really touches y equals 2. But we could say that y approaches or goes towards y equals 2. So all this is saying is that our graph will, as x, our inputs, gets more and more negative, our graph will approach y equals 2. And in this case, when x approaches infinity, what is happening here? Well, our graph will just get bigger and bigger, and there is no restraint to it, so y will approach positive infinity. So again, end behavior is just describing what happens to our graph as x gets more negative, and what happens to our graph when x gets more positive. Okay. Does anyone still need this? Does anyone still need this? And again, these are the answers. I will put more answers up later today. Okay, so the last concept is x and y intercepts. X and y intercepts. So to find the y-intercept, you plug in x is equal to 0. And to find the x-intercept, you plug in x is equal to 0. So what I mean is that we're going to actually use our original equation. So f of x is equal to 5 times 4x plus 2. So to find the y-intercept, you're going to plug in. So to find the y-intercept, plug in x equals 0. So when x equals 0, our graph will cross the y-axis, or sorry, the x-axis. So this will be the x-intercept. Sorry, it's reversed. Yeah, but yes, this is correct. So to find the y-intercept, you would plug in x equals 0. So what we're asking is that when we look at this graph here, where is it going to cross this line, right? Where is it going to cross this line? So all we do is we do f of x is equal to 5 times 4 to the 0 power plus 2. And then we get 5 times 1 plus 2, which is equal to 5 plus 2, which is equal to 7. So we get that when we plug in 0, or when we cross the y-intercept, the y value is 7. So 0, 7 is our y-intercept. You can see that I also solved for it in the table. So if you already solved for it in the table, you could have just put 0, 7. The second thing we can solve for here is the x-intercept. So to find the x-intercept, you want to plug in y is equal to 0. So something I want you to note is I want you to think about this practically. The x-intercept would be where this line crosses this line right here. So many of you might be wondering, well, it obviously doesn't cross this line, because if it can't get under y equals 2, there should be no x-intercept, right? So you could either prove it graphically. You could look at it and be like, well, it's obviously not going to have an x-intercept, so I can stop there. And you would just write that in your test. There is no x-intercept, just by the graph. Or algebraically, if you want to prove it, you could go ahead and plug in 0 for y. So we get 0 is equal to 5 times 4x plus 2. We minus 2 on both sides. And then we get negative 2 is equal to 5 times 4x. We would divide by 5 on both sides. We get negative 2/5 is equal to 4 to the x. And then just as a reminder that when you're trying to move the exponent to the front so you can divide stuff and get rid of everything, you would take the ln of both sides, right? The natural log, or you could do regular log. Does anyone know why I would stop right here? Why would I just stop right here? And this helps me to know that there is no x-intercept. How would I know this at this point? Remember that it's a rule that we remembered. So remember, why do we stop here and go, okay, I know there's no x-intercept at this point? Okay, so the concept is you cannot take a natural log or a log of a negative number. The reason you can't take a log or a natural log of a negative number is no matter the base, it will never create a negative number, right? No matter the base, with a positive base, a natural log of e or 10, you're never going to reach a negative number. So it doesn't make sense practically. Mathematically, you can never reach that negative number. So at this point, we know that there is no x-intercept. So again, you could have discovered this just by looking at the graph and how you graphed it. You could have been, oh, okay, it's approaching the asymptote. It's never going to go below the asymptote. Therefore, I know there is no x-intercept. Or algebraically, you can prove that there is no x-intercept. Okay, I want to show you what it looks like when we do have an x-intercept. So if you look at number 8 on your problem, which is the corner one, we have f of x is equal to 3x minus 2 minus 1. So in this case, we would just plug in, again, you plug in for y is equal to 0. We have 3x minus 2 minus 1. We add 1 to both sides. All I'm doing right now is I'm solving for x. I take the ln of both sides, ln of 1, and what this does is it moves the x minus 2 to the front, and I have ln of 3, ln of 1. I divide by ln of 3 on both sides, and I get x minus 2 is equal to 0, and then I add 2 on both sides, and I get x is equal to 2, or 2 comma 0. Okay, so if I plug this into my calculator, some of you are wondering, how did I get that? If I take the ln of 1, that equals 0, but ln of 1 divided by ln of 3, that is equal to 0. And then I have my x minus 2 left. I add 2 on both sides, and I get x is equal to 2. So if you're wondering what that looks like on the graph, it actually looks like this. So you can see here that at the point 2 comma 0, I have my x-intercept, right? I have my x-intercept. So what I solved for there was just that I have an x-intercept at 2 comma 0. Okay? You could have also discovered this just by looking at the graph, and you could have been like, oh, okay. Or you could have plugged in that value 2 comma 0. So if you find that you have an x-intercept and it's like a decimal or something, I would recommend using this method to the right. If you could just find it out graphically, you could just go ahead and use it from the table that you formed. So you could either determine the x-intercept either algebraically or from the graph. Okay, so I want you guys to work on the first 8 problems of your second worksheet today. And then in 15 minutes, we're